Hello, today is a new lesson about Grasshopper programming and how you can apply it for the steel structure. So this part is how to create beam for our steel structure frame. We will see how we can create red, blue and yellow beam. So this is like each level for the beam. Then let's jump into the algorithm. This is here, and for this purpose I would say it's more convenient to see how it works in Grasshopper. Alright, let's first create beam along Y, I call it. So in this case it will be blue one. This is the most easiest part. We just need to take the dots from the column, from the the same level which we created, and then we should connect these points all together. So, and here there's one trick. For that purpose we will use shift list. So actually these points are list, right? And then that's why if we take all these points and shift them to -1, and then we get these results. You see, we kind of shifted step back, and then we take the same I don't know how to say it, function, and then we shift it step forward, and then we can see these dots, and then we just need to connect them all together. So this is how we can get it. And then just to apply it for the another level, second, third, 5, you see this is the same like for column. So each point relate to the point, to the top points for the columns of each level. I think that's clear. For the beam along X direction, this is a little bit tricky. For that one we need to take a new dots, and for this purpose actually I have a note. It's from a new grid. Why we have a new grid, we can see this is here, and what's the trick? We actually create the same grid, but we rotate it 90 degrees. Okay, I think this is clear how this grid was created. We just take the plane, just we need it just kind of for default. It means really nothing. And then we connect X parameter to Y, and then space X to size Y, and then number X to extend Y, and vice versa. And then we actually have the same grid, but which is rotated 90 degrees. And then we need these points which we put to our beams exactly. And then we can get these points. So, and then we just move it to the height of the first floor. And then we need to simplify this list. We just take geometry, make it simplify, and then make it the same trick and connect these beams. You see, then we have, because we rotated the grid, we rotated the points. You see the different, we have points which is arranged like this, right? And then if we click here, we see the points which is arranged like this. So okay, two lists are shifted and then are connected. So as a result we can get red beams. Yeah, maybe this is there is no detailed deep explanation how list works and so on, but I think through the example, if you repeat it, you can get a correct result, and you also can play. I think you can get the result of what you need. So, and now we go to the secondary beam. So we see here we have a secondary beam which are yellow. We go here, and for them we need to create the points again. So in Rhino this is clear how we do this. My idea that in the first level of the beam we make a point right, with this relative z coordinate, and then we also get another point so just in the column. So this is clear. We just need to also set z coordinate and x coordinate, which is value like 6000, which is from our basic input. All right, and then we create a beam. So we created beam, and what we need to get, we need to get points of this beam, right? So this beam put in the curve and count. This is how many space I would like to get. So, and this is our division number. So this is my approach actually. Based on my experience, I think I prefer to divide it based on the number and not based on the distance, and only afterwards I can see kind of what kind of distance I have. So it's just only example. If you need a little bit specific purpose for your division, you can write a comment or whatever. Maybe I can help you as well. But let's say normally in the project we split the secondary beams based on the number of the spacing, and usually they are equal. Okay, we split it, then we get a points, and the trick is that we now need take only intermediate dots. What I mean about intermediate, right? I need to only this and this, or maybe more, like all except first point and the second point. I think I can add more, then it will be, I think, just better for the example, right? I have 6 and from the 6 I need everything except first and start. So what I need for that? First, this is the most important component, list item. I put the list, all points in the list item, and now I should explain which index, which means what kind of numbers I should take. So right, we see actually that we have a 7 points, 1, 2, 3, 4, 5, right? They all 5, and you know, 6 and 7, so overall 7. And now we see it was taken 1, 2, 3, 4, 5. So what does it mean 1, 2, 3, 4, 5? Actually, if we see 7, the list starts from the 0 index and take the last index. That's why we see here from 1 to 5. But actually, if you imagine, it's taken from 2nd to 6th. Okay, let's just see in detail. We should measure kind of like to know what the length of the list. So then we understand, Grasshopper understands that, okay, it's 7, right? So 7 we put in A, and then we need to delete 2. So overall, what kind of result we get? We have 5, right? This is clear. And now another component, series. So we should say, take for me a special number of the items from the list. So, and now we put all 5 to count. So it means that it will take 5, but we need to explain him what is the start. Start is 1, which actually the second number, and then these settings will be put in the index, and so, and as a result, you know, Grasshopper will take 5 points except first and second. This is really important to understand how list and other things works. I hope it's clear for you. Yes, if you have any questions, you can ask me. But I think anyway, if you repeat it, you can get a result, I'm sure. Then we get these points, and now actually this is a really routine procedure. We just need to take to move these points to another beam, right? We move it by the vector xyz. So we define y size, where to move, and then we just connect the first point, second point. Okay, we have secondary beams in one cell. So what we should do next? we should do, we should multiply it, right? So for that purpose we use linear array, right? So we get this result. Geometry, this is our beam, put here x direction, this is x parameter from our basic input, distance between column, and then count how much. It's also the parameter from our previous input. Okay, and then we actually use the same function array but multiply it to the y direction, and here we created all secondary beams. So, and okay, this is our result. We can go to Tekla, how to export from Rhino to Tekla. This is our standard algorithm. Probably I don't need to explain it in more detail, so let me just maybe explain one. So what we did all the same. I think absolutely the same procedure like with a column. We define material and profile. We collect all geometry and put it in curve, and put it in the beam as a tree, and then we define class, what other parameters which we need, and position, of course. For example, I prefer to align it based on the top, so it means that kind of, if we say this is our level 5 meters, so that's why the level of the floor match with the top flange of the beam. Okay, and now the same procedure for all the beam. You see, it's absolutely the same. Then I don't want to explain it in detail. To know how to do export from Rhino to Tekla, you can watch my previous video, link will be in the corner. And okay, I hope it was useful. I think now we almost done our steel structure. So what do we need to add in the future? I think only bracings. I already have it in my algorithm, in my program. So I would say I will show you next time. For now, thanks for watching, like, subscribes, and I hope it was useful for you. Take care, bye.